This lesson covers multiple representations. Multiple representations just refers to the 4 different ways that you can represent a math problem. Okay. This isn't really working for me, so we'll just write it. So you can write it verbally. So this is in words. You can write a graph. You can have a table or chart. You can also have an equation. So all of these represent the different ways that you can do a math problem. So here would be a table. The input always goes on the x-axis, and the input means what you're putting into the problem. And the output is like your answer, what's coming out of the problem. That always goes on the y-axis. So when we look at this, our input column is over here, and our output column is over here. So just like with our sequences stuff, we need to figure out what is happening. So when I increase from 2 to 1, or sorry, 2 to 3, which is an increase of 1, I'm going up by 3 units. Now this one looks a little bit different. It's increasing by 2, but notice up here, we're going up by 6. So if you considered that there was a 4 in there, that 4 would go up to 14. So that increase makes sense because it's making 2 jumps there. This one's making 3 jumps, so you should expect your next term to be 3 times 3, which is an increase of 9. So 17 plus 9 is 26, and then that would continue to go into y. So the increase was 3. I multiply that by the term number, so this term number was 2. 3 times 2 is 6, plus 2 gives me the 8 that was my output. So this is just like you're coming up with your rule like we did on sequences earlier this week. So 3 times 3 is 9, plus that 2 makes 11. 3 times 5 is 15, plus the 2 makes 17. 3 times 8 is 24, plus the 2 gives me my 26. So when I write my equation, it's 3. If the term number is x, we're going to add 2 to it, and that's going to equal y. So this table helps you come up with an equation that we are now going to graph. So I'm going to start counting by, this is 0, 1, 2, 3, 4, 5, 6, continue to number. And when we number these, we do want to number all the way to the edge of the graph. And we want to keep our scale constant. So if I'm counting by ones, I need to continue to count by ones. Now over here, I have to go all the way up to 26, and I don't have enough spaces for that. So I'm going to count by 2. So 2, 4, 6, 8, and so on. Now we always do want to label our x and y axis. Our x-axis in this case is just the input, but eventually you might actually have, oops, I misspelled that. So this is our input, and this is our output. And then you just graph your points. So when I was at 2 for a term number, that was at 8. When I was at 3 for a term number, that was at 11, which will be halfway between 10 and 12. And 5 was 17. And 8 was 26. Now you do want to use a ruler for this. I can't necessarily use a ruler on mine, but when you use a ruler, you should be able to line up your points. Continue your graph all the way to the edge of each side, and hopefully your line turns out straighter than mine. Okay. So now our input is 3, which means our term number, and we're going to multiply, or sorry, we need to find what our increase is or our decrease. In this case, we're going down by -2 each time. And notice over here, I'm only going up by 1. So that increase should be the same every time. However, on this one, I'm going up by 3. So 3 times -2, this change should be -6. So it gives me -21. And then my last one's going to be y. Now it's time to come up with my process. So it's -2 times my term number. -2 times 3 is -6. But to get to -11, I have to subtract 5. -2 times 4 is -12, but to get to -13, I have to subtract 1. Hold on just 1 second. Sorry, had to figure something out real quick. The reason I messed this one up is because -2 times 4 is -8. So -8, how do you get to -13? You also subtract 5. Now notice when I did that just a second ago, I kind of messed myself up. I made a mistake, and I thought this should be -1. The reason I knew I made a mistake is because these should end up being the same in this process column because you're getting to where you're making the same equation. So just a way of double checking yourself. -2 times 5 is -10. So again, I'm subtracting 5. -2 times 8 is -16. So yes, again, I'm subtracting 5. So to come up with my equation, it's -2 times x minus 5. This line right here gives you your equation. And then it's a matter of graphing for us. Now, we have a positive input, and again, your inputs go on the x-axis. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Except my y values are negative. So when you think about this, this is a coordinate plane. So my negatives are going to go down here. I need to go to -21. So I'm probably going to need to count by maybe 3s, 3, 6, 9, 12. Yeah, that'll work. So I'm going to put -3, -6, -9, -12, -15, -18, -21. And now I plot my points. So when I was at 3 for my input, I was at -11, which should be somewhere right around there. When I was at 4, I was at -13, should be maybe there. And when I was at 5, I was at -15, which should be right about there. And remember, these should be creating a straight line. And then when I'm at 8, I'm at -21. So if you have your ruler, this is going to be a way that it's going to help you kind of keep your information straight, is because you'll be drawing a straight line with that ruler. So here's an example of the verbal. We're going to take that verbal, input the information into a chart or a table, and at the end of that, we will be coming up with an equation. So Jonas currently has 20 songs downloaded. He downloads 8 additional songs each month onto his iPod. So after 1 month, he started with 20. He has 8 additional songs. So he should have 8 additional. So we're going to do, he started with 20, and we're adding to that 8 songs per month. He started with 20. He added 8 songs per month. So in this case, 20 plus 16 should be 36. 20 plus 8 times 3, that's 44. 20 times plus 8 times 4. It's going to be 52. Y is our last one. 20 plus 8 times the number of months. There's where my equation comes from. Okay. Now notice on this one, it's written in a little bit different way. That's okay. I prefer you to use the variables that are given in the chart. So I would like to see this as an X. And because we are writing an equation, it should have an equal sign. Notice it doesn't matter whether you put the 8x plus 20 or whether you put 20 plus 8x. That's the same thing. Now we're going to graph. So with our table, we started going 1, 2, 3, 4. So that's going to be my input value. So I'm going to start down here and say 1, 2, 3, 4, 5, so on. And remember to label all the way to the edge of the graph. A little bit later on in the year, we're going to start making predictions using graphs. So you're going to want to be able to see all those numbers so that you can make predictions in the future, which is why you need to get used to that now. Notice I'm labeling my axis. That's good practice. You should do it too. There will be points deducted if you do not. On this one, we have to go all the way up to 52. So I'm going to count by fives. So 5, 10, 15, 20, 25, so on. And then my first value was 1 in 28. Oops, wrong direction. So 1, I should have been at 28, which is going to be somewhere around there. 2 was at 36, and this is also where using a ruler can help you out. 3 was at 44. And 4, I think it said 52. Looks about right. Now again, notice that all of this should make a straight line, and it should go from edge to edge of the graph. And then don't forget to label your axis. So we went from a word problem to a table, created an equation, and then graphed it. Those are the 4 steps of multiple representations. That's it. All right. Verizon has a plan that costs $20 per month, plus 25 cents for every minute used. So if we think about this, we start out $20 regardless, but then they're going to charge 25 cents per text. So that's how I came up with 2025. Now if I send 3 texts, that's 75 cents plus my $20, so I should get 20.75. So 20 plus 25 cents times 10, 25 cents times 10 is $2.50. So we should be at $22.50. And then 20 plus 0.25 times 20 is $5 plus the $20. So it's $25 for the month. So our equation should be 20 plus 0.25x, and that should equal y. Oops, sorry, they gave me a variable up here, so it should actually equal c. And I erased the wrong thing. Okay. So now we need to graph. And I need to go all the way up to 20, correct? Yes, 20. So I am going to count by, let's say, 2s. So 2, 4, 6. Okay. And then I had to go up to 25. So I'm going to count by 2's over here as well. And typically it doesn't matter what you choose for your scale, but you do want to try to choose the smallest scale possible to represent your data. That way you could see everything really stretched out. On your testing quizzes, most likely I will choose your scale for you, so you don't have to worry about it too much. So this was the cost, and this was the number of text. So for one text, it was $20.25. So one is right about there, and I'm looking at $20.25. So maybe right about there. And then we're looking at 3 for $20.75. 2, 3 for $20.75 should be just slightly above that, close to 21. 10 should be $22.50. So here's 10, and I need to go up to $22.50. And again, lining up your ruler on this can really help you kind of estimate these values. And then 20, I was at 25. Notice it's making as straight a line as I can draw. You should be using a ruler. All right, so that's all we have for today. Make sure you complete your assignment on the next few pages in your booklet.